Okay, bear with me. First time I've ever done something like this, but I figured it would be easier for you guys to hear this than to have Mr. Richmond try and teach this. So today we're going to be going over lesson 72, which is graphing logarithms, and we're also going to talk about some natural logarithms. So starting out, just recall your logarithms are defined as the inverses of exponential functions if their bases match. That means that they are inverses. So you can see right here, we've got a 3 with the base. You've got a log base 3 of x here. Their bases match, so these two are inverses of each other. And you want to remember that with inverses, they do cancel. Okay, so we're going to go ahead on the next slide here. Recall again. Okay, log base 3 of 81, just like we talked about on that last slide. If you have a log base 3 to some power, those things are going to be inverses. Okay, so our first step on this is we need to rewrite this 81 here so that it is a 3 to the 4th power, because now I've got a log base 3 of something and a 3 to some power. So those two are inverses, so therefore they will cancel. So your answer is what's left over, which is 4. Okay? Same thing over here. I've got an 8 to some power, and I've got a log base 8 of something. Again, these two are inverses. Their bases match. So therefore they would cancel, and your answer is 4. If I can get this thing to work. There we go. Okay, and all that we went over there is just everything that we went over with lesson 64. Okay, so now we're going to look at these from a graphing standpoint. So starting out again, remember logarithm is the inverse of an exponential function, which if we recall what our inverses mean that our x's and y values are switched. Okay, so we're going to start out with our exponential function over here, and we're going to look at y equals 3 to the x power. Okay, remember when we do this, we made our chart. We knew our x values. They were -1, 0, and 1. And then after that, we just filled in. -1 went with the reciprocal of our base. So our -1 is 1/3. Reciprocal of 3 is 1/3. 0 always goes with 1. And 1 goes with your base, which would be 3. Now, we're dealing with our inverse. So the inverse of 3 to the x would be y equals log base 3 of x. And inverses, you just switch the x and y's. That's the main rule that you have to remember with your inverses. So we're just going to create a table for this logarithm, and all that's going to happen are your x's and y's are switched. Okay, so if I look over here at my exponential function, my x's I knew were -1, 0, and 1. Now I know that my y's are -1, 0, and 1. My x's and y's have switched. My y values were 1/3, 1, and 3. Now my x values are 1/3, 1, and 3. Okay? So, in summary, you're going to know your y values when you create your chart. It's going to be -1, 0, and 1. So -1 will be paired with your reciprocal now. 0 will be paired with 1, and 1 will be paired with your base. Okay, and the only other thing that we need to talk about this is with your exponential functions, you had a horizontal asymptote. So your reverse of that, for the logarithm function, you need to make sure that you include a vertical asymptote. So again, just in summary, we've got a new parent function for our logarithm. -1 goes with your reciprocal, 0 goes with 1, 1 goes with your base. Okay, so everything's the same, except this time we know our y values. And the only other thing is it's going to have a vertical asymptote. Okay, so I need to graph the parent function of y equals log base 4 of x. So I'm going to draw my table just like I did with my exponential functions, except this time I know my y values are -1, 0, and 1. Base of my function for this logarithm is a 4, so -1 goes with the reciprocal, so it'd be negative 1/4. 0 goes with 1, and 1 goes with the base, which is 4. Okay, so now I'm going to go ahead and graph this. I'm going to go 1, 0. I'm going to go 4, 1. I'm going to go 1/4, negative 1. A little close there. And then the only other thing that I need to add is my vertical asymptote. Okay, and then I just go through and I connect the dots. And that right there is your parent function for the graph of y equals log base 4 of x. And typically that's what your logarithm functions will look like. Okay, let's go ahead and try another one. I've got a y equals log base 5 of x. So again, you know your chart. We know our y columns this time. Negative 1, 0, 1. Negative 1 goes with the reciprocal of your base. So it'd be 1/5. 0 goes with 1. 1 goes with your base, which is 5. Plot those points. Oops. Draw my asymptote, and I just got to go through and connect my dots. Okay, so nothing too crazy there. Go to the next slide here. What about our shifts? Okay, remember we talk about our inside and outsides of our function. Your outside, anything that occurs on the outside of a function, they cause the vertical shifts or flips. Anything on the inside of the function causes your horizontal shifts. Okay, so outside is going to be anything out in front of our log, okay, or anything back behind it, usually added or subtracted. Okay, and then the only thing on the inside is this part that's in here in the logarithm function. Okay, not the base, inside the x or the logarithm function there. Okay, and there will be parentheses around it. If you have anything inside of parentheses, that's going to be a horizontal shift or flip. Okay, let's go through and practice some of these shifts here. I've got a y equals log base 2 of x plus 2. Notice the x plus 2 is on the inside of the parentheses. Okay, so that's going to be a horizontal shift. So I'm going to start graph my parent function real quick. Need to adjust. Okay, so on the inside, it's going to cause everything to shift to the left 2. So my asymptote's going to move over 2, and each of my points are going to move over 2. Okay, so nothing too crazy there. Shifts are all the same. It's just anything inside of the parentheses. Okay, next slide. We've got a log base 3 of x minus 3. Okay, this could be written just a log base 3 of x minus 3. Okay, notice the minus 3 is not in the parentheses, so that's going to be an example of a vertical shift. Okay, so parent function, still the same. Draw your vertical asymptote. Okay, I've got a 0, 1, 0, 3, 1, 1/3, negative 1. Okay, so there's the graph of my function. Now, we said again that minus 3 is on the outside, so that's going to be vertical, and that's going to shift it down 3. So your vertical asymptote moves down 3, although you can't really tell that it does because your vertical asymptote stretches to negative infinity, infinity. But each of these points you will see moves down 3. Okay, so we're good on that. Nothing too crazy there. Next one, I've got a log base 4 of negative x. Again, negative is on the inside of the parentheses. Now remember, your negatives cause reflections, okay? So if it's on the inside, it's going to be a horizontal reflection. So parent function again real quick. Plotting each of my points there. Negative 1 goes with the reciprocal, 1 goes with 0, and 0 goes with 1, and 1 goes with your base. Okay, now the negative's on the inside. So it's going to be flipping horizontally, which is flipping over the y-axis. So that point shifted from over there to over here. Other point here. I need to recalibrate my screen. So that would be that shift for graphing our logarithms. So again, the shifts, nothing's really different. The only thing that's different is what it looks like. Anything inside of the parentheses, horizontal, same as it's been all year. Anything outside the parentheses is going to be vertical. Again, same thing it's been all year. So that's basically summing up your graphing of logarithm functions. If you guys have any questions, I'm sure Mr. Richmond could answer them for you.